The present value of a lump sum. This is normally the value now of some money to be received or to be paid in the future. So maybe somebody gives you a promise of 1 million to be received 3 years from now. You want to know what is the value of that money now. That, of course, is important for you in making a decision. Maybe this 1 million to be received in 3 years' time is equivalent to maybe 600,000 that is received immediately. And therefore, you might prefer to receive the less amount today than waiting for the bigger amount to come in the future, because in that case they are equivalent. So that process of getting the value now of a future sum of money, we call it discounting. It answers the question of what is the value now of some money to be received or to be paid in the future. Look at this example. Assume you were to receive 172,800 3 years from now on an investment, and the required rate of return is 20%. What amount could you receive today to be indifferent? What that means to be indifferent is that what is the equivalent of 172,800 to be received in 3 years' time? What is the equivalent right now if the required return is 20%? So that if you receive it right now, then you don't have to wait for 3 years. So how do we proceed to do that, to answer this question? And I will remind you that we said in getting the future value or some present sum of money, we said it's the present value into 1 plus k raised to n. This is what we said in some earlier lecture, that for us to get our future value, we compound the present value. So we can now make the present value the subject of this formula. So we say present value is equal to the future value divided by 1 plus k raised to n. If we do this, then we are getting the present value. And this formula can actually be written as, we can say the present value is equal to the future value times 1 plus k raised to negative n. We can rewrite this formula that way, so that the present value is equal to the future value multiplied by 1 plus k. Of course, consistently we are saying k is the rate of interest, or we sometimes call it the required return. The required return. And of course, n is the number of periods, or years in this case, number of periods. And this value that we are calculating here, we give it, we normally call it the present value interest factor. So that is why if you find a formula that tells you that the present value is equal to the future value times the present value interest factor at the rate of interest k in n periods, this is still the same formula as this. But we know at the back of our mind that in getting our present value interest factor at the rate of interest k in n periods, we know is 1 plus k raised to negative n. So in this question, we are told here that we are to receive 172,800 3 years from now, and the required return is 20%. What amount do we receive today to be indifferent? So you can as well say this, that the present value is equal to 172,800, which is the future value. Multiply this by 1 plus the rate of interest is 20%, 0.2. This is raised to negative 3. And then of course this is 172,800 times 1.2 raised to negative 3. We can solve that. We can solve what is regard the present value interest factor. So 1.2 raised to negative 3. Sorry, that is a mistake. 1.2 raised to negative 3. That is 0.5787. So this is 172,800 times 0. Say it is 0.5787. 0.5787. And where does that lead us to? So 172,800 times 0.5787 is roughly 100,000. 100,000 is 99,999. It's 100,000. So in other words, instead of waiting for 3 years to receive 172,800, if you receive 100,000 right now, it is equivalent to 172,800 to be received in 3 years' time, as long as the required return is 20%.